And so on. Oh, I got this up here, so Ryan, if you want to come over here, come on over here, Ryan. Yeah, you see him, I brought him. I didn't want to move any of Mrs. K's stuff because I like it. In the back is my school. So go ahead, Ryan, you're tall, you can get it. And then pass it on. That's something I found at, yeah, just grab them. So this is number 7, right? Let's see if I'm on track here. Number 7. It says number 6 and number 7. Okay. It's all equations, right? Yeah, what's up? So number 7. And a little I guy, right? So here we go, Mr. Upper. It says the length in centimeters of trout in a fish farm, right? Big deal. 96% of the lengths are less than 34, and 70% are a certain length, okay? So make sure, yes ma'am.
What paper?
I am doing, I know, there's so many I gave you, and I do that. I will keep me on track. Me too. It says sanity practice problems. It's a tab. Just write on it Cambridge, okay?
Yeah.
That helps? All right. Yes, exactly, okay? So I'm going to make sure I have the right one. So if I don't go over the wrong one. Yes, numero 6. Numero 7. All right, so here we go, right? So the first thing we got to do is figure out what, I believe.
The probability that x is less than 34.1 is equal to 0.96.
34.1 is what, 96%?
Yes.
I'm just listing some information I got. And what's this other one? 26 point, what, Mr. Upward? 7?
That x is greater than 26.7 is
70%.
0.7. Yeah.
I'm just doing this in my head, okay? All right, so now we got to figure out the z for each one. We got to figure out, no, not the z, but the mu or something. The mean, right?
And the standard deviation.
And standard deviation. There we go. So we're going to start off this way, right?
So
X minus mu over for every one of them, right? All right. So I'm going to just do this, right? The first one. So you probably already did this one, Mr. Upper. He's going to go, hey, you go 34.1 minus, I don't know, over what?
Sigma.
Sigma.
But then,
now, talk to me.
So you look for 0.96 and find
In
the
the table,
corresponding
right?
z-score.
Boom, table. That's a probability, right? And then table.
It's 1.751.
1.751, and then he's going to get a mu of?
Mu. Or then we have another equation, then we use substitution or elimination to solve for both variables.
Oh, yeah. So, okay, so I'm going to do this one here, and then I'll set this one up as well, right? And then we got 26.7 minus mu over sigma equals, and then you look this guy up here in the table, and you get what?
For 0.7.
Yeah, 0.7, what do you get?
0.476.
0.476? Really?
I think I did 1 minus that.
Yeah, it's 1 minus that, right? For some reason. Why is it 1 minus?
Because you can only do to the left, less than,
Right.
when you're plugging into that formula.
That's a pain in the neck, okay? And what did you get then?
So, 0.476. Right?
0.476?
That's 1 minus whatever.
So 1 minus
corresponding
0.476?
Or no, it's 1 minus something is equal to 0.476.
So this is 0.476?
Yeah. Right.
They didn't get 0.476. He did 1 minus the z-score, right? For 70%, 0.07.
Which is
And he's 0.476, right? So instead, okay, I already saw it. Yeah, if you can fit it up
Why are
there.
we putting this on the fire alarm?
Why not? Because I don't want to hang it up. I don't want to disrupt Mrs. Case. You guys are tall. See, I had it
0.524.
perfect. So we're going to use, instead, Mr. Up, we're going to use 0.5 what? Instead of subtracting, we're going to use the value that's 0.7.
It's 0.524.
There you go. Okay. 0. What again?
524.
524. All right.
Let's
That's
come
what
up.
they used. Oh, go ahead. Yes.
So would it still be okay if you use the 0.467?
I don't think you'd be that far off, but personally, I would use the 0.467.
Where did the 5, 2, 4, 5?
This is in the table. You go table 0.7000 and look it up in the probability table. Nick.
So whenever you plug into that formula, you have to use the probability.
I think so.
That's- a z-score
that's
that-
how I read it.
So,
Less than the mean. Yeah.
Yes.
I don't have the paper in front of me, but
That's okay.
You said something like trout and length.
Yes, trouts.
Yeah,
Yeah.
I'm going to say like it's 34 inches. There's a 96% chance of getting a 34 inch fish.
And then there's a 70%
Right,
chance
and
of
those
so
are
on.
the z-scores for the percentages.
Yes,
Okay,
yes,
yeah, right.
yes. Okay, not bad. Now, well, okay, I got some things that are not known here. So what do I do?
Solve for one in terms of the other for both. And
So, yeah, gee, I'm listening.
yeah, so multiply by sigma on both sides.
So, for each one individually?
Yeah.
Okay, so for this one, I thought I get a better color. I brought this from Sammy's pack here, you know? So, sigma here, right? Sigma there. And then, do I need to go through it further or no?
Yeah.
Are you okay? Because I still have an unknown variable, don't I?
Yeah.
Mm-hmm.
So what would I get here? So I get 34, 1.1 minus mu is equal to 1.75.
One sigma.
I'll go through the whole thing, okay? 34.1 minus mu equals 1.751 sigma, right?
Yeah.
And like he said, hey, multiply this by sigma again, and then equation 2, right?
Yeah.
26.7 minus mu equals 0.524. We're going to use it.
And then
Simultaneous equations.
And can you set mu equal to whatever?
Yeah, you can multiply 1 by the negative to kill off the mu, because then you get the sigmas. Make sense?
I use substitution.
Well, it doesn't matter.
I was gonna say, I mean, when,
You got to get rid of one of them,
I was
right?
gonna say in my mind, I would just,
Well, see, there's a 1 mu and a 1 mu, a 1 u, 1 u, right?
oh, okay.
Uh-huh.
Oh, you're canceling down.
So you're just
Yeah. Now, if you want to, you can substitute, but you're.
elimination is easy.
Yeah. So, is it okay if I just do this? It doesn't matter, right? It's negative 1. Now, I'm just going to give you the answer. Is that okay?
Yeah.
Okay. So, Mr. Upper's absolutely right. So, Mr. Upper, did you get 28.4? Roughly?
for sigma.
Yeah, okay. Yeah, you're going to get 28.4 for mu.
I got
What did you get? Because remember, you had
5.8.
Oh, 5.8. I'm ahead of myself. So instead of
Well,
you, you're going to get what?
28.4.
He got 5 point something. They got 3.25 because they did what? This was yours was 4.6 something.
So it's okay to use a z-score that's corresponding to a probability that's greater than x, not less than x. So
Yes,
that's okay.
That's fine. I'm going to use what they did. Is that all right?
Yeah.
So they got 3.25, and then you plug it back in, and then you get sigma. Am I right on this one? Oh,
It's 28.
the sigma's here, and then 28.4.
And that's your average.
All right. So you multiply 1 by the negative and kill it off. All right. Not bad.
Oh, wait. Oh, that's the sigma for the other one?
Well, this is the sigma for both of them, right?
Second one is
The mu. Okay, all right. my bad.
Yeah. Remember, you have two unknowns, right? So simultaneous equation 1, simultaneous equation 2.
Wait.
System of equations.
Okay,
Okay.
so the sigma equals 3.25,
Yes.
and then mu is.
And then you plug in. Then you take any equation and plug it back in and get the
label
mu.
the mu as sigma. That's why.
That's why. So I did what? Did I label it wrong?
At the
Yeah,
bottom.
last.
The last one. Yeah.
Yeah, it should be.
Thank you. Because I'm doing backward. All right, so that's I, right? Now I got to do double I. All right, double I asks what? Double I asks, find the probability that a random chosen salmon of 34 to the nearest centimeter. Okay, so this is the one where you have to go half and half because, you have 34, so they're going to figure out everything in between 34. Does that make sense?
So
Okay.
choose.
So instead of saying 34, they say, well, to choose everything there, they're going to go 34.5, and I should say 33.5 and 34.5. Okay,
Or
Would it be 0.4 because 0.5
because you're
comes up?
you're rounding down, right?
33.5. I'm rounding down, and then I'm rounding up. Right?
Is that what they
Well, 33.5 rounds up to 34, which is what you want. But wouldn't it be 34.4 because that rounds down to 34?
Did I? Hold on. I know Caitlin's like, what is he doing? What they did, they had 34.5, and they had for the x, your random variable, which is x, right? This is x.
Mm-hmm.
They did this in halves, right?
Yeah.
Makes sense. That's okay?
Yes.
Caitlin? Talk to me. Because it's 34, right? And so you got to find out everything that's within the 34. Hello? All right. Okay. So now the next thing is I'm just going to do z-scores again, right? So what are you going to do here? I'm going to take this minus this guy. Is that all right?
They're probabilities.
Right. So I'm going to write it this way, okay? So I'm going to go 34.5 minus what?
Your previous, what we got out of
The mu?
28.4.
28.4? I do they have something different? That doesn't make sense, but all right. This is,
That's X minus B.
yeah, but they have something different, all right? I would have used 28.4. That doesn't make sense for 30, but that's. They use 32.9. Where did they get 32.9?
Oh, it's in that question.
Say again?
The other problem was about trouts, the new set's about salmon. They just.
They give you the
It's
new.
different.
Oh,
they give us 32.9.
Oh, they give you 32.5 for the salmon. Oh, okay.
0.9.
Oh, so given. I didn't see that. Okay.
32.9.
So the mu here is 32.9. Okay. I didn't see it. It's really hard for me to see. So this now is 32.9. Okay. Because they gave it to you.
Yes. And the standard deviation is 2.
And that's 2.4. They gave. I'm sorry, guys. They gave this to you for the second problem. So go away first problem, right? And go to the next double I. And this is 2.9. All right. Or 2.4. I was right. 2.4. Okay. Now the next set of stuff is what do they do next? 33, right? 0.5 minus the given over the given. Okay. I think the hardest part, and then now Ryan, why did we go half and half for 30 to find out the 34?
Because it's linear centimeters, so if you measure a fish and it's those lengths, you would round to 34.
Right. You go to the last. If you want to get 34 inches or whatever, you're going to do a half an inch and half an inch, half a centimeter, half a unit, half a unit. 0.5 would be this. Yes. Sir.
For point I changed it and I got 6.03 for a sigma, so
6.03.
I'm still not.
I can't. What did you get for sigma? Remember, this is given to you in the problem, right?
Well, no, this is for part I. Yeah.
For this guy right here,
For I. We're on I right now.
I'm on double
Yeah.
I.
He's going back to I. He got a
Oh.
different sigma than you did.
I gotta look. I'll look in that
Okay.
for you in a second. All right. So continue with this one, right? You're going to get a value, right? You're going to get, I think, 0.667. Yeah.
Yeah.
And this one here, you're going to get what? 0.5987. Okay. Yeah. This minus this divided by this. This one.
Makes sense.
Makes sense.
That's the Z scores, right?
That's the z-scores. Beautiful.
So you find the two probabilities.
So now, watch what I'm going to do. Right? Look it up. This means I go to the table and I look it up.
Oh, that's not the.
That's what they do.
So the
Yes.
reason why you separated it was to take into account the rounding, right?
Yes.
So wouldn't it be 34.4 rather than 34.5? Because if you round 34.5, it goes to
It goes to
35.
Yeah.
34.4. 34 point. No, they didn't do 34.4. They did 34.5.
Really?
They went half and half.
Yeah, but when you have 5 to round up, you don't round down.
Yeah.
I think that here's 34,
So they're
And-
just going half
Right.
down and half up.
half here on the z-score on the thing. That's what they're doing. Remember? There's my z. This is really my z of 0, something like that. You know, because that's the mean, and that's a.
the mean.
Well, this is the random variable, right? So
Yeah.
here,
Yeah.
and then here. That's what I'm doing. This is random variable where you're not fluctuating at all here. So you're finding the stuff in between here and here, the probability. Yes.
For that second one, how did you get 0.5987?
Well, they gave it to me, but what did you get?
See, I got 0.25 as the z-score.
0.25? Okay, I'm ahead of myself.
Yeah.
Because yes, you're right. 0.25. It's hard for me to read, and that's too bad. I shouldn't. All right. So now you're going to look this one up. You're going to look this one up, right?
Yep.
What did you get for this guy right here? 0.6,
0.44.
0. What?
4.
667? Remember, it's in the table.
Yeah.
What did they get?
I got 0.44. Wait, is that
Really?
20?
No, we already have the z-score.
This is the Z. This is the Z. Call it the lower Z, the higher Z, right? And then this is. So what's 667? That's what you got?
No.
No. So you go 0.6 and then. There we go.
Yeah.
There we go. 7.74777.
Yeah.
Okay.
There we go.
Good. Next. 0.25.
0.5987. Yeah.
What am I going to do with these haters?
Subtract.
And then I get the probability that I'm going to find that salmon, right?
Yeah.
0.149.
There we go.
Right? That's the probability of finding the salmon 34 centimeters long or whatever it is.
Wait.
Yeah, I'm listening.
7 minus I'm getting 1.99.
Where are you getting,
7.77.
sorry, where are you getting,
Oh.
is it me?
Oh,
No?
okay.
Never mind.
Am I okay? I'm okay? You tell me, like, what are you doing?
Good.
All right?
4 was a 9.
Mr. Epler, not bad?
Yes, good.
Not bad. Okay, we're okay here?
Yep.
I know it's period 2. I know what period 1 was. This is my period 1, right? So I go through this all the time. All right, do triple I? What? Triple I?
Yes.
Triple I, good.
I think that
All
was
right,
a problem.
is there a triple I with number 7?
Yes.
All right, let me get through with it, right? Oh, gee whiz. Can I raise?
Yes.
All right, here we go.
And it's on video, so.
And it's on video. Oh, boy.
We have 5 minutes.
5 minutes, hurry up, Murmer. All right, so tomorrow's Thursday, right? So I will give all of this to you Thursday. So you like have an idea, like, oh, practice, all right? So triple I, all right? Hurry up, Murmer. All right, Mr. Upper says, hey, find the value such that, okay, value of t such that you get this, p 31.8 x, I don't know, equals a certain probability of a half.
Okay.
All right, here we go. Not a half-life. Okay. So what are we going to do? We're going to do another z-score, right? So we know it's the probability of this guy minus the probability, actually this guy minus this guy. You always reverse it, okay? So here we go. We're going to go the probability, or I can just go z, right? So I'm going to go this guy, t, minus what? Now what is it? 30. Remember, we got it from the previous problem. Is that right? What is the mu? What's the
mu.
average? We just did it, didn't we?
Yes.
Yeah. It was from, you're going to borrow it from double I, right? Which is to 32.9. You see the mean of 32? So this is 32.9. So you borrow info from double I. All right? Now, it's going to be t minus 32.9 over what?
Sigma.
Sigma, which is?
2.4.
2.4. Okay?
And that equals 0, right?
Well, we're going to find
Yeah.
out. Right? Not bad so far? Yeah? Yeah?
Yeah.
And then we're going to go minus, okay? What's the next one? 33, not 33, 31.8, is that right? That was given to you, right?
Yeah.
Minus 32.9 over 2.4. Okay. How are we doing so far?
Good.
Now remember, you're going to get a value, you're going to get, I don't know, and you're going to,
Oh, yeah, don't you know?
well, don't you know?
I knew
We don't know T.
You'll know the probability of the
And all this jazz equals what?
0.5.
Yeah?
So
Here we go.
get the z-score and the probability.
So, I don't know, right? And what am I going to do with this one to make this more interesting? So, I'm going to start here. So, this is the same, okay? Minus, and remember, 5 means you look up the z-score. You get a z-score, look it up, all right? And so, I'm going to just do what? Instead of getting the value here, what am I going to do? I'm going to do that little trick there, remember?
Multiply everything
Not
by.
every, yeah, well, no, not yet, not yet. I'm going to do what with this one? 1 minus the z, right?
Z.
I'm going to take 1 away from whatever the score is. That's what they did. And it says use two standard deviations. That's how we do it. All right. So what they did was they got a value here. So they go 1 minus whatever this value is. Anybody want to tell me what this value is? Me too. 0.67 whatever. 0.6765.
Negative 0.458.
Really? This comes. So it comes out to negative 4 point.
Yeah.
Then you look it up.
Yes.
Right.
And you have to look up the positive and then do 1 minus that
Right.
probability.
Yeah, this one sucks. I don't like it, so don't worry about it. So I'm going to continue on with this, right? So I get a number here. I don't know what's here, so I still go minus 32.9 over 2.4, and then minus this. You get some number here. You look it up. You throw it to the other side, and then you finally get 0.8235. Now, all I do next is to solve for t, and then I find out what the random variable is. This one is. I don't like this one because it's sufficient. It tells you, it's an occult thing. That means you don't know where it is to find this guy out. You know, you have to subtract it from 1. Right, I think that they just said, hey, take this value, look it up, take it, and move that over, and then change the sign, and then do this. Yeah.
I thought that you just had all that equal to 0.5. You multiply everything by 2.4, then solve for t.
Well, 2.4, 2.4, 2.4. Yeah, you probably algebraically can. The only problem is if you do what you just said, this says you got to find the score first before you have to get the value before you multiply it by 2.4.
And what do you do with the score?
Well, then when you got the score and so on, remember this is unknown. So you don't know this value yet, right? So this is encompassed in here. You can't find that value out. So you can't really multiply this all by 2.4.
So you don't need to change the probability into a z-score.
Correct. Okay? I know that this one I didn't like, but okay. Go ahead.
So then it would be that t minus 32.9 over 2.4 minus the z-score of that junk in there.
Yeah, whatever this is, right? And then minus, whoop, you look it up, you got it, and then move it over.
Okay.
And then you get a value. And that's the value that they got. And this will be coming tomorrow. I'll make copies later today. All right? We'll do one more tomorrow if you want. And remember, it's like 3 Poissons, 3 dead fish, and then I'll tell you a little bit. I'm going to be a little more directive. All right? And then you'll get the ammo tomorrow. All right? Not bad? Mm-hmm. And make sure you know that you all are smarter than Patricia Heaton. Okay? Even though she's worth about $30 million. Okay? Remember, being rich doesn't mean you're smart. Doesn't. Sometimes it means the opposite. The direct opposite. All right, so here. All right, I go right here. Yeah, this one I can understand is difficult, but I'm looking for straightforward ones, okay? I think my shirt's coming out. Yep.